Good morning. Our paper is identifying and analyzing noisy spelling errors in a second language corpus. It's by me, Alan Juffs, and Ben Naismith from the University of Pittsburgh Department of Linguistics and Duolingo. Our research context is intensive English programs and writing accuracy. English orthography is challenging for learners of English as a second language, and this is compounded by the influence of L1 orthography. Spelling accuracy is critical in high-stakes tests like TOEFL and the Duolingo English test because spelling errors will affect vocabulary scores. So we had two goals: automatically detect, correct, and analyze unpredictable spelling errors in learner writing, and provide feedback to teachers and learners who provided the dataset. The dataset overview. We had 5,774 L2 essays from the Pittsburgh English Language Institute corpus. We had a total of 1.8 million words from that corpus. We had learners from 5 L1 backgrounds: Arabic, which uses an abjad, where vowels are not reliably marked; Chinese, which has logographic characters; Japanese, which has a mixed logographic and syllabary system; Korean, which has a stacked alphabet; and Spanish, which is a shallow orthography. We also had 3 proficiency levels, from CIFAR A2 to C1, low intermediate, intermediate, and advanced. The methodology was that we used Python, SimSpell, and spell checker-oriented word lists that excluded clang associates, that is, words used incorrectly that are actually real words. For example, learners might use hem for the word hymn, and of course hem is a real English word. The statistical model that we used was the Hurdle model, which is used for data sets that contain scores of many zeros and scores that are over-dispersed. We normalized the data by counting the number of errors per 100 words. Technical details of error detection. First, a scowl list was created that included words in the corpus, not in the dictionaries. For example, learners might write words like onsen, hot spring, or frisbee, a toy. SimSpell was used as a checker because it's fast, accurate, and avoided false positives 100% of the time. However, SimSpell can't catch clang associates and focuses only on single words and bigrams. Most of the 5,774 texts were error-free, although at level 3, low intermediate, learners did make many errors. For example, this graph shows that 40% of Arabic speakers' texts at level 3 contained at least one spelling error. Moreover, at level 3, Arabic-speaking learners made reliably more errors than other speakers. However, as this graph shows, by levels 4 and 5, intermediate and advanced, no reliable differences were found among the first language learners. Errors decreased reliably from level 3 to level 4, indicating that the learners were able to use their spell checkers appropriately. Qualitative review showed that L1 orthography played a role at low intermediate level. Arabic speakers omitted vowels and spacing, whereas Chinese and Japanese learners inserted vowels to make English comply with the L1 syllable structure. More advanced learners' errors were more often loanwords and non-English acronyms, as well as errors caused by deep English orthography. Implications. Data mining and spell checking tools can cope with L2 corpus data that contains a variety of spelling errors. Human raters may unwittingly and unfairly penalize some L1 groups based on the statistical analysis. Learners are particularly vulnerable at the lower levels. Therefore, early instruction on lexical quality, which includes orthography, is important. Limitations and future research. Clang associates needed further work for part of speech and context to cope with the him-hem type error. Smarter spell checkers could be used that recognize non-English acronyms and proper nouns. Finally, L1 error types could be used to create L2 specific spell checker tools. Conclusion. Scowl lists and SimSpell are efficient at identifying and correcting errors in these kinds of data. L1 and proficiency level affect spelling error patterns. Results of such data science in education can be looped back to teachers through comprehensible presentation of results that includes qualitative examples as well as statistical results.